All right, let's talk about artificial intelligence. You hear the term AI everywhere, right? It's powering our world in ways that are, frankly, kind of mind-blowing. But what does it actually mean when we say a machine learns? In this explainer, we're going to pull back the curtain and look at the surprisingly simple logic behind how machines go from knowing absolutely nothing to making some seriously powerful predictions. So, let's just start with something we've all experienced. You finish binging a show on Netflix and boom, instantly the perfect next recommendation is right there. How does it do that? Is it some kind of magic? Well, not quite. It's AI, and the way it works is actually a lot more straightforward than you might think. So, before we get into the nuts and bolts of the how, let's just set the stage. What is AI, really? Let's start with a really simple, foundational definition.
At its heart, it's really just this. We're training machines to mimic human intelligence. The ability to think, to learn from new information, and to figure out solutions to problems. Think about Google Maps learning the fastest route to your house, or even your phone figuring out the next word you're going to type. That's this core idea working in the background.
Okay, so that word learning, that's the real key here. To really get a handle on it, we're going to zoom way in on a classic, super simple example of machine learning. So forget about complex robots for a minute. Let's talk about something way more down-to-earth: house prices. For a machine to learn anything, it first has to understand relationships. Specifically, the relationship between a cause, which we call the independent variable, and an effect, the dependent variable. So in our little example, the size of a house is the cause, and the price of that house, that's the effect. The price depends on the size. This is the basic connection our AI needs to figure out. And how does it do that? Well, it uses a formula you might actually remember from math class: y equals mx plus c. In this case, y is the price and x is the size. The machine's entire job is to just find the perfect numbers for m and c to make its predictions as accurate as possible. So, the training begins by feeding it data. Lots of it. We give it a big list of real houses. A 1,000 square foot house costs this much, a 2,000 square foot house costs that much, and so on. You can imagine each of these as a little dot on a graph. This is the machine's study material. So here's the crucial part. The machine's goal is to draw one single straight line through all of those data points. But it can't be just any old line. It has to find the one line that is, on average, the closest to all those real-world dots we gave it, the line with the least possible error. So after trying thousands, maybe millions of tiny adjustments to those m and c values, it finally draws that perfect, best fit line. And this line? This is the knowledge. This is what the AI has learned. It's the relationship between house size and price. Now you can give it a brand new house size it's never seen before, and it'll use this line to predict the price. It has officially learned. So that's the basic idea, right? Learning by finding patterns in data. Now let's zoom back out and see what other kinds of problems this same exact method can solve. Our house price example? That's called regression. It's where we're trying to predict a continuous number like a price or a temperature. But AI can also tackle a totally different kind of problem called classification. This is when you want to predict a specific category. Think yes or no questions. Is this email spam or not spam? Will it rain tomorrow? Yes or no? Okay, so we've gone from the big idea to a simple example to different types of learning. But why does any of this matter so much? Well, because this simple process is the engine behind some of the most world-changing technology we have today. I mean, just think about it. This ability to learn from data and make predictions is what lets a Tesla navigate a road using computer vision. It's the absolute core of those recommendation engines we talked about earlier, and it's what drives high-speed automated financial trading systems. This isn't some futuristic idea. This stuff is running on these principles right now, all around us. And if you want to know just how powerful this can be, just look at this number, 35%. That's reportedly the percentage of Amazon's total revenue that comes from its recommendation engine. All of that from an AI that just learned what you might want to buy next. That is the incredible power of machine learning. But it's not all that simple. There's a pretty big challenge in the world of AI. As these systems get more and more complex, their decision-making process can become a total mystery, even to the people who built them. It's known as the black box problem. You put data in, you get a decision out, but you can't always explain the logic that happened in between. And that leaves us with a really critical question for our future. As we hand over more and more important decisions to AI, from medical diagnoses to driving a car through a busy intersection, how can we be sure we can trust its choices if we can't always understand the why behind them? That might just be one of the biggest questions we have to answer as this technology continues to shape our world.